Okay, so we're going to kind of go back over some of yesterday. All right, so first of all, so you might want to have your notes out from yesterday because that'll be helpful to do today, the blue ones. I think they're blue, yes. Okay. That's the homework. That's it. Angel, hold that up. That's it. That. Yes. That's the homework. Miss Rice wrote this, yeah. Yeah. The good teacher gave you notes yesterday. All right. Okay, so 1, 2, and 3, they're asking about the range for the inverse cosine, the inverse sine, and the inverse tangent. So the inverse cosine, what is the range? Look on your little blue paper.
0 to pi.
So it's 0 to pi. So the what? Yes. Okay. So it's 0. This is pi over 2, and this is pi. I know this is the positive side, and this is the negative side of cosine because it's a positive x and negative x. And so this side is my reference angle, and this side is pi minus the reference angle. So what was the range for the inverse sine?
Negative pi over 2 to pi over 2.
And so this one and the tangent both are this way, where this is the positive, this is the negative, this is my reference angle, and the negative is the negative reference angle. And the negative pi over 2 to pi over 2, you get parentheses because those are where the asymptotes are. Yes. So, first of all, I want to remember the inverse we read, where is the sine equal to negative a half? Where is the sine equal to negative a half? So first of all, I just want to find where is the sine 1/2.
Pi over 6.
Is that pi over 6? Okay. So sine is 1/2 at pi over 6. But I want a negative 1/2. So it's negative pi over 6. So the cosine of a negative square root of 2 over 2. So square root of 2 over 2 is at pi over 4, right? But that's the positive one. If I want the negative one, I have to take pi minus pi over 4.
So it'd be 3 pi over 4.
Correct. So you put these over common denominators, and we get 3 pi over 4.
Wait. When you subtract pi, it's because it's in cosine, right?
No, it's because you're trying to get the other side. To the other side. To make it a negative. You can't just put negative pi over 4.
So why do we do that for sine?
Because that's in our restricted.
Yeah, that's in there.
Sam, do you have to draw the picture for everyone?
Oh, okay. I got it.
So I want to know, well, sometimes you have to draw the picture, right? And sometimes you don't. So for instance, on this one, you guys, where is the cosine -1 on the unit circle? It's at pi, right? So do I have to draw the circle there? No. So that's pi. Is that in my restricted?
Yes.
So I don't have to do anything. I just write pi down. So some of them are really easy, right?
So then do you want it to be in your restricted area?
It has to be in the restricted area. Yeah.
For 10, since it's
Okay, so the tangent of negative 1. So first of all, I know that the tangent is 1 at pi over 4, because that's square root of 2 divided by the square root of 2, right? So that's the positive 1, but I want the negative 1. So if I look in here, where do I get the negative value? Down. So that's a negative pi over 4. That's it.
So you don't have to do the thing you did for number 5 on that one?
Say that again.
Because you know how for 5 you have to do the pi minus pi over 4?
Right, because look, that's for cosine, the positive is your reference angle, but the negative is pi minus the reference angle. For sine and tangent, the reference angle, the positive is your reference angle, but the negative is the negative reference angle. That's the way it works. Okay? Okay, so the sine of the square root of 3 over 2. The sine of the square root of 3 over 2 is at pi over 3. I want the positive one, so do I have to change anything? Nope, so it's just pi over 3. Where is the cosine 0, friends? Pi over 2. Is that in my restricted? So I don't have to do anything.
Is it anything that's like underneath the, oh no, never mind, got it. Restricted is the top and the first and the fourth.
For the sine and tangent.
Okay.
For the cosine, it's the first and second. Okay? Okay. All right, where is the sine negative 1? So it is at 3 pi over 2, but we're going to call it negative pi over 2, because that's in our restricted domain, or range. I take off this negative 1 here. That's a typo. So, right, yeah, so we already have that, so we don't have to have both. All right, so I want to know where the tangent is the square root of 3. So we wrote the table down on the front of that blue sheet. Where is the tangent of the square root of 3? Pi over 3. So if it's at pi over 3, but I want the negative tangent, where do I have to go? Negative pi over 3. Okay, and number 7 and 12 are the same, right?
Wait, what does the arc stand for again?
It's the inverse.
Inverse, it means the same thing.
If there were to be a negative 1 on arc, it would just cancel out, right? It would be regular.
Yeah, just be the tangent of a negative square root of 3, and we can't do that, right? Okay, so it won't be there. Okay, so I'm going to come back to number 13. Look at number 14. So here I have the sine of the inverse sine of 0.3. So the sine and so the first thing you have to ask yourself, does 0.3 fall in my area? So is 0.3 between 0 and 90? Yeah, so it falls within the area. So if it falls within the area, these cancel out and we get 0.3. But that's how you have to start. You have to ask yourself, is this in my restricted range? Yes or no? Okay, let's not do that one. Can we go down and do number 16? Would that be in the between 0 and 180? So it's just past 0, right? But it's past it. So it is in the restricted, which means these cancel out. So this is just 2 7ths.
Okay, and if it's not in the restricted area, what happens?
We're going to come back to those, okay? All right, so look at number 21. Is negative pi over 2 in the restricted area? Yes. So that means the sine and the inverse sine cancel out, and it's negative pi over 2.
It doesn't matter if the inverse is on the outside?
Nope. But let's look at number 20 now. So we want to see if I can just cancel these out. Is 4 pi over 3 in the restricted area? Okay, bummer. So if it's not in the restricted area, where is 4 pi over 3? Pi over 3 is 60, right? 60 times 4, 240, which puts it in the third. So here's what you have to ask yourself. If 4 pi over 3 is in the third quadrant, what is tangent in the third quadrant? Positive or negative? So take a look. What's the y in the third quadrant? What's the x? So negative divided by negative is positive. So here's what you have to do. I want a positive tangent. And so I know my tangent is positive in my restricted area. Where is it positive? Top. So what's the reference angle with the 4 pi over 3? Pi over 3, right? Pi over 3. So that's your answer, because that is in your restricted area. And that gives you a positive tangent answer. So did I just throw out the 4? Because what does the 4 pi over 3 do? What does the 4 pi over 3 do? It puts it over here. But what's your answer going to be? It's going to be positive, right? So does it matter if I use the positive one up here, the pi over 3? It doesn't matter if I use this or this. So I'm going to use pi over 3. Because it's the same answer. It's just in different quadrants, but it's the same answer. Which is why we restrict.
Could it be the same in quadrant 1? I mean 2 and 4.
2 and 4 are the same for tangent.
Oh, like on the other side.
Yeah, it's basically right.
Right. So, okay. So I think he asked a question that would. So look, 1 and 3, the tangents are both positive, right? 2 and 4, the tangents are both negative, but it's the same value. It's the same value, but these are negative and these are positive. And that's why we restrict the inverse, because I get 1 positive and 1 negative. It doesn't matter which quadrant it's in, I just want the value, and I want it to be positive. So that's the same in the first as in the third. Does that make sense? The other thing is I could see somebody else asking, how did I get the reference angle? It's always the denominator, right? Pi over the denominator. So that's a 3. That's how I got it. What? It is. Like they come across on a straight line, right? Yes. It does. Always. Okay. So, I want to go back to number 13. So this is another one, we want to cancel it, right? Except they're not exactly the same, but the cotangent is the reciprocal, right? So we can cancel them, but we have to do the reciprocal of what's inside. So this would be 3 over the square root of 3. Can I have a square root of 3 in my denominator? So I have to rationalize the denominator. And they cancel. Yes. And that's the answer. So, yes, it's just the square root of 3. So, the cosecant and the sine, they are reciprocals. So they cancel out, except I have to flip the 1/8 and it becomes 8. Okay. Okay, like number 19. Like number 19, they're not reciprocal, secant and sine. Except I'm looking at the answer and it's square root of 2 over 2. Where's the only angle that's the square root of 2 over 2? Pi over 4. Would it matter if it was sine, cosine, cosecant, or it's still the same, right? They're all the same. So I do have to do the inverse, though. the reciprocal, not the inverse, the reciprocal, right? Because the secant is not the same as sine. So you do have to flip yours, and it only works on the square root of 2 over 2 because pi over 4 is the same for all of them. They're all the square root of 2 over 2. So this one, I'm going to do negative 2 over the square root of 2. I'm going to rationalize the denominator. So I get negative square root of 2. So there's 2 examples left. 2 examples left. And so tangent and cosine are not inverses. And they also 2/5 and 5/13. These are not values that we learned, correct? So what do you have to do for those?
Do it in your head.
Don't we use the formula?
No. No, I think we're going to use the Pythagorean theorem. No, we're not going to do that either. No. So cosine is x, right? So it's negative. So this is negative 2. So does this tell you which quadrant it's in? No. So we're going to make this one in the third.
You just made it like that.
I did.
Make it up still.
What she do? Now if I do that on a test.
No. You can't make crap up on a test. On all the homework, it told you where to go, right? This one didn't tell you. So I got to find the y. You're not making crap up. I can make all the crap up I want. You cannot make crap up.
Miss, when can we use the Pythagorean theorem?
Okay. In any quadrant you want. Go for it.
I don't know how he gets attention back here. It's so hard.
That's what I'm saying. Like,
Okay. So I get that my y is the square root of 21. But what do I know about the y in the third quadrant? So it's negative square root of 21. I want the tangent. So I want y over x. So I get negative divided by negative is a positive. And I get square root of 21 over 2. That's the answer. Positive. So I'm going to do another one. Number 17. And this one, we're going to put it in the second quadrant. It's going to say. I'm not making stuff up. Honey, the radius is always positive. So, this time, so the 5 is negative. And I said it's in the second quadrant this time, so we're going to go this way. This is 13. So what's the y value this time? What kind of triangle is it? 5, 5, 12, 13. Okay, what's 13 squared? Minus 25, square root of 144 is 12. You guys, you should all know the 5, 12, and 13, and 3, 4, and 5. They're all the same. If you don't, do the Pythagorean theorem. All right. So I want the tangent now. Y over x. 12 over negative 5.